All right, guys, 11.7 is a tough section, not going to lie to you right here. So I'm going to do 6 of the 16 problems here with you guys. And I think on every one that I do, there's a corresponding problem that comes right after it then that I'm hoping you guys can try on your own. So we start talking about the surface area and the volume of similar solids here. And if we remember this concept of similarity from back in, going all the way back to chapter 5 with triangles, although we dealt with it in chapter 10 as well with perimeter and area, similar solids, we use this little tilde sign for that, are the same shape but different sizes. So in order for two solids to be similar, all of their corresponding parts would have to be proportional. So when they're asking us in number 1 and number 2 here if these two figures are going to end up being similar to each other or not, what we really need to know is whether or not we have a proportional relationship. So I'm just going to start comparing all the corresponding sides. This 6 right down here in the first figure corresponds to a 3 in the second. So I make a ratio out of that, 6 to 3. That tells me absolutely nothing. But now I look for this 18-meter side here on the left, which corresponds to the 9 on the right. I want to know if this relationship right here works, if it's proportional. And to be thorough about this, I also need to check the heights, 10 and 5. If these figures are similar, all of these ratios are going to be equal to each other. Well, this is a really easy one to see. 6 divided by 3 here really just simplifies to 2 over 1, or just 2. 18 over 9 is 2. 10 over 5 is 2 as well. Obviously, 2, 2, and 2 are all equal to each other. So since all of the pairs of our corresponding parts are proportional to one another, this one here is a yes. But let's just say for the sake of argument, instead of a 10, or instead of a 5, this one over here was a 7. If that becomes a 7, then this right here is not a 2, and in that case, the answer would have been a no. So you got to be careful with that one. Last thing, they didn't ask you for this right here, but the big concept right here when we're talking about similar figures is something called the scale factor. And if you remember back to chapter 10, the scale factor is the ratio of the corresponding parts between two figures. Well, what we found, looking right here, guys, is that in every measurement right here, the first figure was twice as big as the second one. So the scale factor right here would be 2 to 1. That's going to become important later on here in some of the other problems that we have to do. So that's number 1. Number 2 works kind of the same way. Let's take a look at number 3. It says here that each pair of figures is similar. So we've got two cylinders here that it is telling us now are the same shape. Use the information given to find the scale factor of the figure on the left to the figure on the right. So we're looking for scale factor, and they gave us information about volume. So one of the formulas that was in your notes here, guys, that we need to know is this, that the volume of one figure compared to the volume of a second figure is the same as the ratio of their corresponding sides, side 1 to side 2, but that ratio right there has to get cubed. Cubed because volume is a cubic measurement. So this little formula is what's going to guide us through here. Now, let's see what's going on right here. The volume of the first figure they gave us here is 15 pi. So I'll put that up there where V1 goes. And the volume of the second figure goes right underneath it. That's a 120 pi. All right, that wasn't bad. But we've seen some problems like this before, and people tend to get confused because very often, including I think in the problems that I did in the notes for you guys on 11.7, I usually give you one of these two quantities, either side 1 or side 2, and ask you to find the other one. Here, though, I didn't give you either. They didn't give you either. Well, the key here is they're asking you to find the scale factor. This ratio right here, side 1 to side 2, is the scale factor. So I'm just going to leave that as side 1 over side 2 cubed, and we've got to try to isolate the ratio S1 over S2. Now to do that, we have to do two things. First of all, this ratio right here can be simplified. And we could either do that now or later. I'd rather do it now. First thing I want you to notice is you have identical factors of pi on both the top and the bottom that cancel each other out. And then from there, we are now just left with a 15 over 120. So if we go to our calculator and just type in 15, this calculator isn't going to work real well for this, guys. It gave it to me as a decimal. Ooh, but if I hit that, there you go, that little button right next to it, it simplifies that fraction to a 1/8. So where are we now, guys? That left side becomes a 1/8. And that 1/8 is equal to side 1 over side 2, and that whole quantity is going to get cubed. Now, what we're looking for is the ratio of side 1 to side 2. All by itself, we need to get that cube out of there. And this is something I don't think that we had done before this section, guys. To get rid of a square, we do a square root on both sides. To get rid of a cube, we do something called a cube root on both sides. And a cube root looks just like a square root, but we put a little number right there called an index of 3. And then, of course, I have to do the same thing on the left that I did on the right. Now, the reason that this worked in the past is because the exponent was 2, and without an index drawn there in a square root, that number's a 2 as well, a square and a square root canceled each other out. Well, here, a cube and a cube root cancel each other out as well. So this entire right side here simply becomes side 1 over side 2. The cube is now gone. And now we need to do this calculation, the cube root of 1/8. And that's going to be a little bit different on every calculator that's out there. But for us, for me, I've got a square root button right here all the way on the left. Just to the right of that, there you see a radical with a little n for the index. So let's see. I might have to put the 3 there first. Nope, that did not work. Let me clear that out. So I'm going to hit that button first. I'll put a 3 there for my index. And now for the radicand, what we are taking the cube root of, I'm going to do a 1 fraction 8. Yeah, and the cube root of 1/8, everybody, is 0.5. Or if you wanted to convert that to a fraction, it works out to be 1/2. Okay, so where are we? The ratio of side 1 to side 2 is 1 to 2. And what they asked us to find was the scale factor. Guys, what we just have right there is the scale factor. It's a 1 to 2 ratio. Now you'll notice for their answer, they wrote that ratio with a colon, and that's perfectly fine. So you can either do the colon or you can do the fraction. Both of them are equivalent ways of expressing the same ratio. Now what that means, everybody, if you take a look, the volume of this second figure is a lot bigger than the volume of the first figure. In fact, it's 8 times as big. But if we were just measuring one little linear component right here, that piece right there, that radius compared to that radius, what we would find here, everybody, is that the radius of the second figure is only twice as big as the radius of the first. So maybe this piece right here has a length of 5 centimeters, then this one over here on the right would be 10 centimeters. So the radius, the length, is twice as big. In fact, let me just show that real quick. What's happening here is that the radius is times 2, but the volume is times 8. That's because 8 is the cube of 2, and that becomes important right here. 2 times 2 times 2 gets you 8, and that's why your volume increases as much as it does. Okay, number 4 is a similar problem. I think 5 and 6 are as well. Let's move on then to number 7, where things get a little bit more challenging as well. Weird thing about number 7, you have to read carefully. They're actually asking you 3 different questions here. Okay, so what's going on? Each pair of figures is similar. Yeah, you're going to see that a lot. We're supposed to find the scale factor of the 2 figures, then the ratio of the surface areas, and then the ratio of their volumes. Well, remember that scale factor is a ratio as well, so we're actually supposed to come up with 3 ratios for our answer. So let's do this in order here. To find your scale factor, you're simply going to take the ratio of 2 corresponding sides. Now, because they already told us that these ones are similar, I can just go with one pair of sides. The 50 kilometers on the left corresponds to the 90 kilometers on the right. I don't really need to do the 30 and the 54 also. So I'm just going to go 50 over 90, and I'm going to simplify that fraction, and I really hope everybody at this level can do this without a calculator. You just divide by 10 and cross out that 0, and you end up with 5/9. That doesn't simplify any further, so that's your scale factor. Now, by the way, if you had chosen to do the 30 and the 54, greatest common factor of those two numbers is 6. 30 divided by 6 is 5, and 54 divided by 6 is 9, and lo and behold, you get the exact same answer. So that shouldn't surprise you. If the figures are similar, you're going to get the same scale factor either way. Second thing they want is the ratio of the surface areas. So the formula we would use here, and I haven't written this one down in this homework video yet, it was this formula, that the surface area of one figure compared to the surface area of a similar figure is going to be equal to the ratio of their sides, side 1 to side 2, but because we're talking area, that's going to get squared. Okay, so with that in mind, what do we know? We want the ratio of the surface areas. This fraction right here is the ratio of the surface areas. So actually, let me just put an equals sign right here and keep going. The ratio of side 1 to side 2, that's exactly what we found right here, guys. So the scale factor is 5 to 9, and we're going to square that, because surface area is a square measurement. And the 5 squared on top is going to get us 25. The 9 squared on the bottom is going to get us 81. And that is the ratio of your surface areas. And the last one we wanted was the ratio of the volumes. Well, volume 1 compared to volume 2 in similar figures is your scale factor, side 1 to side 2, and that quantity is going to get cubed. Well, this scale factor is exactly the same as the one that we used right here in step 2. It's this ratio there, so it's 5/9, and that's now going to get cubed. And the 5 cubed up on top, that's 5 times 5 times 5 is 125. And the 9 cubed on the bottom is 729. Everybody knows that. Probably not. And that is the ratio of your volumes. So again, they were asking you 3 questions, but there it is. There's the scale factor. You square that ratio to get this one right here, and then you cube that ratio to get this one right here. Okay, that's where we're at there. That was number 7. 8 is similar. Let's look at 9 here. Okay, what's going on here? The scale factor between two similar figures is given. So they told you the scale factor here. Gotcha. The surface area and volume of the smaller figure are given, and we're supposed to find the surface area and volume of the larger figure. So let's do surface area first. So the formula we just talked about in the last problem was surface area of 1 to surface area of 2 is equal to side 1 to side 2, and that's quantity squared. Okay, so what's going on right now? They're telling us here that the surface area of the smaller figure is given right here. So the surface area of the first figure is 176. We're supposed to find the surface area of the larger figure. Now that equals this ratio right here, guys, side 1 to side 2, that's your scale factor. So this is going to be a 2/5 squared. Okay, let's start off by squaring that fraction there. 176 over surface area 2 is going to equal, squaring a fraction, you really shouldn't need a calculator for this, guys. Square the top to get 4, square the bottom to get 25. Now we're going to cross multiply. 4 times surface area 2 is just 4SA2 equals, here I need some help, 176 times 25. 176 times 25 is going to get us 4,400. All right, so that is 4,400. And the last thing we would do there is just divide both sides by 4 to get surface area of the second figure. Should just be 1,100 if I'm not mistaken. We would take that answer, divide it by 4, and that gets us 1,100. Whoop. Here we go. That gets us 1,100. Everything was in square meters now, so that's the surface area of the larger figure. All right, let me switch to blue. I think I can cram in the volume problem here. All right, so now to find volume of the larger figure, the formula here is volume 1 over volume 2 is equal to, we've got side 1 over side 2, and that quantity is going to get cubed now because volume is a cubic measurement. So the volume of the smaller figure here is 512. We're looking for the volume of the second figure. The scale factor hasn't changed. That's still 2/5, but now that's going to get cubed. All right, so cubing the right side, we're going to get 512 over V2 is equal to 2 cubed, that's 2 times 2 times 2, which is 8, and the 5 cubed is going to be a 125. Cross multiplying, 8 gets multiplied by V2, can't do anything with that, but now the other cross product is big and ugly, 512 times 125. 512 times 125 is equal to 64,000. Big number there, 64,000. And lastly, guys, to get V2 by itself, we're just going to divide that number, 64,000, by 8. So I'm just going to hit answer divided by 8, and that gets us 8,000 now for the volume of that second figure. Volume units were cubic meters here, so it's going to be cubic meters here as well. Okay, so that's a tough problem there, and yeah, they stay tough. Let's keep going with number 11 here. All right, some information about the surface area and volume of two similar solids has been given. We're supposed to find the missing value. So what's going on in number 11 is they've given you information about surface area for two figures. We're supposed to come up with volume. What we would really like is if we had a formula that related surface area with volume. Unfortunately, we don't. Both of those things, separately, surface area and volume, relate back to side lengths. So since we know more information about surface area, I'm going to go with this formula here. Surface area of 1 over surface area 2 is equal to side 1 over side 2 quantity squared. Let's get going with this now. Surface area of the first figure is 100. Of the second figure is just 16. That's going to equal, and I'm really just looking for the scale factor here, guys, side 1 over side 2 squared. Let's just do this trick right off now. To get rid of a square, we want to do a square root on the right, and we balance that by taking a square root on the left. So the square and the square root cancel each other out on the right-hand side. And so now, let me switch sides on you. We're just going to get side 1 over side 2 equals, and the square root of 100 over 16, well, both those numbers are perfect squares. The square root of 100 is 10, the square root of 16 is 4, and then you could also divide a 2 out from both of those numbers right there and end up with a 5 over 2, and what you just found right here, guys, is your scale factor. That's pretty darn important. Now, that's not our answer. But the scale factor can be used to find the volume of the second figure. So let's go back to this formula now. Volume 1 over volume 2 equals your scale factor, side 1 over side 2, quantity cubed. Okay, volume of the first figure, they tell us, is 16,000 cubic kilometers. We don't know the volume of the second figure. But now on the right, S1 over S2, that's our scale factor that we found right here, everybody. So 5 over 2 is what goes there for the ratio of your corresponding sides. Okay, I'm going to cube that right side, so the left side is going to stay the same. 16,000 over volume 2 is equal to, that's a 125 on the top, and a 2 cubed is going to get you an 8 on the bottom. We're going to cross multiply. The 125 is going to get multiplied by the V2, and the 16,000 is going to get multiplied by 8. So we're at a 125 times volume 2 equals, and I don't know, 16,000. Oop, that didn't come out right. Let's try that again. 16,000 is going to get multiplied by 8 to give us 128,000 for that other cross product. Okay, and the last thing we need to do then here, guys, is to divide both sides by that 125, our coefficient right there, and it's going to be just over 1,000, I think. Let's see where that gets us. So 128,000 divided by 125 is going to get us 1,024. Whoops, lost you there. All right, 1,024, and volume units here were being measured in cubic kilometers. Whew, so that was a lot of work right there. We had to use the information given about surface area in order to find scale factor. And then once we found scale factor, we had to come back up here and use that to find a missing volume. Whew, so that one is tough. And really, number 14 is the same problem as the one that we just did. It just went in the opposite direction. Now, they've given you more information about volume, and we've got to figure out surface area. So let's start off with volume because we know more about that. V1 over V2 is equal to side 1 over side 2 quantity cubed because volume is three-dimensional. The volume of the first figure is 16,038 over the volume of the second figure, much smaller, 2,750. That equals the ratio of side 1 to side 2 quantity cubed. We want to get rid of a cube by taking a cube root. So we're going to do a cube root on the right, oh boy, and a cube root on the left. The cube and the cube root cancel. So our ratio now of side 1 to side 2, or our scale factor, let's just do all this in the calculator here, guys. We need a cube root of 16,038 over 2,750. All right, how are we going to do that? A cube root, so I hit this button here, cube button there, got it. And then for our fraction, here we go. It was 16, I forgot the numbers already, 16,038 over 2,750. 16,038 over 2,750, and that worked out pretty nicely, guys. I got 1.8 for the answer, and if I convert that to a fraction, 9 over 5 is what I'd really like to see there. So that is our scale factor, 9 over 5. Now, that's not the answer to this problem, but you need the scale factor in order to move on into the second part, where we're looking for information about surface area. So let's go with this formula. Surface area of 1 compared to surface area of 2 is equal to the ratio side 1 to side 2 squared. Okay, surface area of the first figure, the larger one, is 243. We don't know the surface area of the second, so we'll just call that SA2. And that equals, well, side 1 to side 2 is what we found right here. Your scale factor is 9 to 5, and we need to square that. Okay, let's simplify that right side. 243 over SA2 is equal to 9 squared is 81. 5 squared below it is 25. Let's cross multiply. 81 gets multiplied by surface area of figure 2, and that is equal to the product of 243 times 25. 243 times 25 is going to get us 6,075. Okay, and then last step from here, and we're done, we're going to divide both sides here by 81 and get surface area of figure 2 is equal to 6,075. So last answer divided by 81 gets us 75, a nice clean number there. So 75. Surface area units here were square feet, so that's where we're at. 75 square feet for the surface area of the second smaller figure. Guys, 11.7 is a really tough section, so spend a lot of time on it. Have this video handy as you're going through it, and post and let me know if you guys have any questions. Good luck.